Hey, hi guys. So this is your tutorial 5 for your topic 3, the heat and thermal insulation in building. Okay, so there's about 6 questions in it, so let's get on with it. So the first question is theory is to define the specific heat capacity and state its unit. So the specific heat capacity is a material, is a quantity of heat energy required to raise the temperature of 1 kg of that material by 1 Kelvin. So this is the meaning of definition of specific heat capacity. So the unit is in joules over kg. Either that in is either in degree or is in Kelvin. Okay, so for question number 2, so you have to compare and contrast the difference between sensible and latent heat. So sensible heat is heat added that result in a rise of temperature, and then latent heat is a heat added that does not result in a rise of temperature. So this is the difference between these two. Okay, so question number 3 is to list 7 factors that affect the rate of heat losses. So this can be found in your lecture slides. So the first is the insulation of building shells. So better insulation, lower rate of heat loss. Exposed area of building shells. So if you have a large area, then you will lose more heat. And then temperature difference between inside and outside of the building. So higher temperature difference, higher rate of heat loss. So because if you have a difference in temperature inside your building and compared to outside of the building, so temperature they will want to try to make themselves equilibrium. So they want to be the same in the same temperature lah. Also, okay, the next one is air change. Exposure to external climate, so higher frequency of wind blowing, higher rate of heat loss. Efficiency of service in the building, so some wastage of heat energy used for water or space heating, and then reuse of recycle the heat energy used. And finally is the pattern of use for the building. So different pattern of building usage, different rate of heat loss. Okay, so next we have our calculation question. There will be about 3 of them. So in total, half of them is theory and another half is calculation. So the first calculation question is to ask you to calculate the total heat energy required to completely convert 1 kg of ice at 0 degrees to steam at 100 degrees Celsius. So the specific heat capacity of water is 4190 joules per kg Celsius, and then the specific latent heat are 335 kg. And then for ice is 220 kilojoules per kg for steam. So this you are already given all the information. So this is the same exact method for your as shown in your lecture slides. So you have to make use of the formula, which is the MC temperature over the theta, sum of the temperature, and also this. So the mass and the latent heat, you multiply them, you're given the latent heat is at 335 for ice. So to convert ice into water, you have to have their latent heat into multiply by their mass. So this is to convert the different state of ice into water, but the temperature is not rising. So you just multiply them together. This is the first part. So for the second part, to convert this water to 100 degrees Celsius, you will have to use this formula. So the mass and the heat capacity, which is this 4190 joules per kg Celsius, and then multiply by the temperature difference. So with that, you will get about 419 kilojoules. And then finally, to convert the water into steam to a different state of matter, you have to use back the same formula again, which is ml. So the mass of 1 kg converting it to from water into steam, the properties required to change this state to another state is 220 as given here, the specific latent heat. So you just multiply them together and you get this energy required to change water to steam. So from this three state, from ice, from 0 degree ice 1 kg to 1 kg 0 degree water, it requires a specific amount of energy, which is 335. And then from water, from 0 degree Celsius to 100 degrees Celsius, it requires another specific set of energy. And then finally, from water to steam, 100 degrees, same, a change of method, it requires another set of energy. So if you add them together, you require a total energy of 3014 kilojoules. That's the total heat energy required to convert 1 kg of ice into 1 kg of 100 degrees Celsius steam. Okay, so for question 5, you're given a house with a 92 meter square area and a ceiling height of 2.5 meter. And you're also given that the temperature inside is 18 degrees Celsius and outside is 6 degrees Celsius. And the average infiltration rate is 1.5 air change per hour. And finally, you are given the heat capacity of the air is 1300. So you are to calculate the ventilation heat loss. So given all this value, so which is your CV, which is your specific heat capacity, 1300, and then N is your change of air, and V is your volume. So volume 92, which is here, meter square, and the ceiling height 2.5 meter. So you multiply them together, you get it in meter cube. And then the temperature difference, which is 18 minus 6, which is 12 degrees. So using this ventilation heat loss formula, you substitute all this value in, you get that the ventilation heat loss is 1495 watt. So this is pretty straightforward on the application of this formula. Okay, so finally we have this final question, question 6. So you're given area, which is 14 meter times 4 meter times 3 meter, and 20% of this wall area is glazed. So it is glass and the door have a total area of 6 meter square. So the U value, which is in this, for the wall is 1.6, window 5.5, door 2.5, floor 1.5, roof 1.5, and floor 0.8. And then the inside temperature is maintained at 18 when the outside temperature is -2. So this is a temperature difference. And then you're given 4 air change per hour, and your specific heat capacity of the air is 1300. And finally, you have the total heat gain of total 2200. So you have to calculate the net rate of heat loss from this building. So all the information are given. So in this case, when the question mentioned glaze, so this is a window Okay, so you first off you have to find out the total heat loss, because there's a fabric heat loss in this building, so you have to find out first. So there's a lot of material in this building. So for the door, it's a 6 meter square. So you put it in, and then for your window, you know that your window is 20% of the wall area. So your wall area can be obtained from these three sides of the building. So 11 plus 4 multiply by 3 and then times by 2, and then this 20%, this is your window area. So the remaining area is the wall, and the floor and the roof, which is from this. So you'll get the U value from which is given here. Wall is 1.6, window 5.5, door 2.5. This is your U value. So using the formula of the total fabric loss, which is P equals to UA, and then multiply by the temperature difference, you'll be able to get the fabric loss. So the total fabric loss is just accumulated sum of all this value lah, of all the component from the door, window, wall, floor, and roof. So 2.5 with the area 6 multiplied by the temperature difference. So the temperature difference is 18 minus negative 2. So minus minus become a positive plus. So 18 plus 2 equals to 20. So this is how you get for the temperature lah. So you multiply them together, you get a set sum of total fabric loss. And with that, you need to find the ventilation heat loss due to the change of air change. So using this formula, the fabric heat loss formula, and with all the information provided, here it shows the temperature, and then the volume, number of air change, which is 4. Here, you can obtain from the question itself, 4 air change per hour, and your heat loss is the specific heat capacity is 1300. So you got all the value to get your fabric heat loss, which is 3813. So you got this and you got this, and the question told you that there's a heat gain of total 2200 watt. So add them together and then you minus out your heat gain, you'll get a heat loss of 8029. So this is how you do it for your tutorial 5. So if you have any question, feel free to ask now. So thank you for listening.